In this video, I talk about how to visualize finding the area between curves by integrating with respect to y. To help us visualize this, I'd like to use a problem from James Stewart's Single Variable Calculus Early Transcendentals 6th edition. The problem is to find the area between y equals x minus 1 and the curve y squared equals 2x plus 6. I have graphed the two curves. Now, I'd like to have us visualize integrating with respect to y. So in order to do that, I think it's helpful to imagine the y-axis being horizontal instead of its normal vertical position. So I'd like us to first imagine the negative end of the x-axis down at the bottom. It's kind of like how the negative part of the y-axis is normally at the bottom for us. So let's do that. So x is now our vertical axis, and the negative numbers are at the bottom. Now y is our horizontal axis. However, there's one problem with our horizontal axis, and that's that the negative numbers are on the right side of the number line and the positive numbers are on the left side. So in order to adjust for that, we need to imagine ourselves sort of looking at the back side of the paper and looking through to see where the ink is. In order to help us visualize that, I'm just going to flip the paper over. So now the numbers that used to be on the right side, those negative numbers, are now over here. And same thing for the positives, they've come over to the right side. So what we can do is we can renumber our y-axis. 1, 2, 3, 4. Of course, this is 0. We can see the vertical axis kind of bleeding through the page. -1, -2, -3, and so on. I'll also number our vertical axis. Of course, it isn't essential for us to number the vertical axis, but I'll do it anyway so we can see. All right, so we have our axis. Focus a little bit, camera. All right, thank you. So now we are going to do the same process that we used earlier when we were finding the area between curves with respect to the x-axis. So we identify our limits of integration by seeing where the curves intersect. So the curves intersect at -2 on our horizontal axis, and they also intersect at 4 on our horizontal axis. So then we're going to integrate from -2 to 4. We're going to integrate with respect to y, and then we need to do the top curve minus the bottom curve. So then the bottom curve, we typically call it g of x, but if we're integrating with respect to y, we're going to call it g of y instead, and we'll call the top curve f of y. Now, let's think of what the equation of this straight line was with respect to y. Okay, let's see. Here we go. With respect to x, it's x minus 1, but if we add 1 to both sides, we have x equals y plus 1. So we could say that this straight line is y plus 1. So straight line is f of y, y plus 1. -2 to 4. Minus g of y. Let's see what we need to substitute in place of g of y. So we don't need to go back to the other side of the page. We could kind of figure it out based on what this parabola looks like. You know, we've got a parabola. It's shifted down 3. It looks wider. But easier way is just going to be go back here. We have y squared equals 2x plus 6. So then we're going to subtract 6 from both sides, divide both sides by 2, and we have 1/2 y squared minus 3 equals x. So this will be our g of y, 1/2 y squared minus 3. 1/2 y squared minus 3. Now it's all integration. We're going to distribute the minus, do a little simplifying. -2. So at this point, we're just going to do some antiderivatives, plug in 4, plug in -2, subtract the results. You can do that on your own. The main point of this video was to help you to visualize integrating with respect to y. So I hope it was helpful. Take care.